The resistor, so here's a resistor in the circuit, is going to act to impede the current. Okay, so we draw a little arrow down here and we zoom into our resistor. So here we go, here's our resistor in the circuit, and it will impede the current. So I want you to imagine these electrons are busy flowing through the circuit, and they come across the resistor, and as they move through the resistor, they collide with other atoms in the metal and electrons, and as a result, when they collide with the atoms in the resistor, they lose energy, and they lose energy in the form of heat. And that acts to impede or reduce the current. So if we then take a voltmeter and we put a voltmeter across the resistor in the circuit, this is actually a way that we can determine how much energy is lost as electrons, or transformed as electrons move from one side to the other. So if we think about, again, in terms of electrons, so we have an electron on this side of the circuit, and let's imagine that it's got 12 joules of energy, okay, because it's part of a series circuit and a 12-volt battery, and we've only got one resistor. As it moves across the resistor and there's a lot of collisions, and it collides with other atoms, energy is lost in the form of heat, or transformed into heat. So therefore the electrical energy that the electron had from the battery is going to be transformed into heat, and as the electron comes out the other side, it has lost that energy in the form of heat. So the voltage is a measure of the potential difference, which is kind of like saying the energy difference across two different sides of the resistor. So in this case, we would measure the energy difference across a resistor as being equal to 12 volts. And what that means is that every electron, as it's moved across the resistor, has lost 12 joules of energy. So voltage, therefore, is defined as the amount of energy per charge. So the change in energy going across a component per charge in the circuit, that is what voltage, sometimes referred to as a potential difference, is defined as. And if we look at the units, our energy is measured in joules, our charge is measured in coulombs. So because it's energy divided by charge, that is equal to joules per coulomb. And of course, that's more commonly just referred to as units of volts. Either way is fine. Now, in terms of trying to understand this a little bit better, you can kind of compare it to gravitational potential energy. So we have like a little picture here which kind of shows that on the left hand side we've got a mountain, and we know that at the very top of the mountain up here, the energy will be gravitational potential energy, defined as mgh. Now as the mass moves down the mountain, it's going to lose gravitational potential energy, and that energy is going to be transformed into kinetic energy and heat and other forms of energy. And so we can think of this ball rolling down the hill in a similar way to defining voltage and what's going on with voltage. So on the right hand side here, we have like I guess you can think of it as a voltage hill, kind of a voltage hill. And at the very top here, so up here, the electrons have electrical potential energy, and they have that from the power source. Now, as the electrons move through different components in the circuit, so as they move through resistors, they are going to give up some of that electrical potential energy, and it's going to be lost as heat through resistors. Now, as they then move down the other side, their energy has been lost, so therefore the difference in energy between this point up the top of the hill and that point at the bottom of the hill, so either side of the resistor, is what we call the potential difference. And again, it is defined as the change in energy per charge is the voltage or potential difference.